what is the difference between a small asteroid and a spacecraft? From the perspective of an orbit simulator, absolutely nothing. So that kind of means that like the part that calculates orbits should not have any knowledge or just shouldn't care about, you know, other additional information about objects in space. Like, objects in space here are referred to as satellites. So the satellite's rotation, the satellite's like, you know, vehicle part data, the satellite's asteroid, whatever. Like it doesn't have to know that. This orbit simulator has to just only do orbit things. So that actually means that instead of making one really big and very complicated system that would just handle everything, that will handle vehicles, asteroids, and planets and everything, and everything had to do with orbits, it actually makes a lot of sense to make some kind of protocol, some kind of interface, so that different simulators can like work on different aspects of objects. Like I can have one simulator deal with rotation, and I can have another simulator deal with position. Like, you know, actually, but yeah, in some cases they'll have to deal with both. Like in a realistic n-body simulation, that the shape of the planet can actually affect the orbits, the things orbiting it. So you actually have to take its rotation in account, because of the differences of gravity above the surface. But in many cases, rotation doesn't matter. So yeah, it's a little complicated. Yeah, of course, it's literally rocket science. I say this all the time, and this problem is big enough that it doesn't all like fit in my head at the same time. I have to like write it down. What am I doing here? Simulation ID. Yeah, separate out the components so that you can have one simulation deal with the rotation, the other simulation deal with orbit stuff and position, and another simulation can deal with like, I don't know, solar panel power output. So there can be multiple different simulations running, and each satellite, each object in space, can have data kind of scattered across different simulations. Like, oh, you want to know the position of the satellite? You have to look over there. If you want to know the vehicle data, you have to look over there. You want to know its rotation, you have to look over there. And at the same time, these simulations have to update at different rates. Like you can like update a solar system simulator like every minute, and it's still like fairly accurate. You don't have to update it at 60 FPS. While some things that are like close to the user can update at 60 FPS. So yeah, instead of making one big spaghetti system, you have to separate it out. And the funny thing here is that it doesn't matter if you're doing n-body, it doesn't matter if you're doing patch conics, or it's something like something complicated or something really simple. Like there's something really simple here. Circular path simulator. You see, it doesn't matter like how simple or how complex the orbital mechanics math is. Like it still needs a lot of software engineering surrounding it to handle stuff like transferring a satellite from one simulation to another, or changing coordinate spaces and stuff like that. So yeah, what's harder than rocket science? Software engineering. Oh god. So yeah, you see, like the way that I'm writing this is that I can keep the simulators as simple as possible. See, this is just like plain old C++. That's a struct. You have, position, velocity, acceleration. This is like radius around the center, period, initial time, and ID. And you just have to like call this update function with a time multiple times. And that would just do sine and cosine to rotate around. So I actually have this thing. This is like the only thing that I have sort of working right now as for the new universe stuff. So if I start this you say it's just like it's a little it's the physics scene. but inside here we have a circular path. So we can keep these keep the simulators stupidly simple, but at the same time add some kind of interface so that, you know, other things can read into it, or you can like push satellites to it, or you know, you can get satellites stolen from it or something like that. And in that case, you know, we can avoid making some spaghetti monster. As well as you can also like mix and match different types of orbit simulators. So you can have like, I don't know, patch conics for the solar system, but each individual planet or asteroid has n-body around it or something like that. It also cleans up things like landed objects on planets and other things like that. Because if you just look at a satellite, just look at like a spacecraft, and then you ask the question, how does this move? It can be like on the surface of a planet, it can be flying above a planet, it can be orbiting a planet, or you know, maybe it can be parked at a Lagrange point or something like that. But either way, like I think this is headed in the right direction. And okay, universe structure. What I was gonna do here is remove something called satellite sets. So this was the thing that I was thinking of adding, but now I'm thinking of not adding it. And that's as easy as going into here and then satellite set and just delete every instance. Like at least a second, save that. Delete all of these. Delete, 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 delete. So I was thinking of like, you know, if you have like multiple different simulations running, the simulation should be able to create satellites on their own without needing to interfere with each other. So I added something called a satellite set so that they can just create identifiers for satellites. They can just create and delete satellites within their own little field without, like, satellites that they quote-unquote own. But that doesn't really work because satellites are owned by multiple simulations at the same time. So, like, the system doesn't actually work. You know, this satellite set, don't need that. And where's the big universe? There's no main universe, like, struct. Like, it's all just... no, what is that? I don't know what that is. Time? Universe, yeah. Where did I delete? Components, is it data accessor? Data accessors. Data accessors. Maybe UCTX component. Where did I delete satellite sets from? Maybe if I just like change this to satellite IDs. Satellite instance. Satellite instances. Yeah, there we go. Because we're going to be keeping track of an instance. Like there can be a satellite, and its rotation can be handled by one simulation, and its rotation and its position can be handled by something else. And those two simulations just have the same satellite ID. And there's some other organizational stuff around there, like data sources, which can refer to, which you can use to get a satellite and be able to know what simulations its data comes from, so we know where to read. Okay, that's confusing. I think that's all I had to do here, and then I have to just fix all the errors that broke, because instead of our sat sets, this is now sat. Instead of sat sets, this is sat ints. Satellite instance. I don't want to call it an instance manager. That would be horrible. Satellite instances. Because it's dealing with whether satellites exists or not. It's like If it doesn't have an instance in satellite instances, then it doesn't exist. Sat inst. So when the universe core is created, this thing will create one of the struct of satellite instance. And this one is the test planet thing will have to read from it. So satellite instances. And we're not going to be creating a satellite set ID anymore, so we don't need that. So sat inst. No, this is not going to be needed anymore. Satellite sets not. It's actually the entire thing's not going to be needed anymore. Satellite instance.id. So that just simplifies that down. Satellite set doesn't exist. Satellite set doesn't exist. Data sources. Or just it's just that sat inst data source. Sat inst ID's capacity is pretty much just having one satellite set for everything instead of having supporting multiple satellite sets. This is a sat inst utxcx satellite instances are sat inst. And this doesn't, that assert doesn't have to be there anymore. I like removing asserts. What's that? Yeah, that's the planet drawing thing. It has to keep track, actually, all of this complexity of needing to keep track of its satellite sets and stuff like that, this wouldn't be needed anymore. Which means I can just... Where is it? Just... Planet draw. It still has satellite set ID. I have to remove this so that it starts to. Satellite set owner. If that's removed, now all of these will be tracked chord space, tracked sat set. This can just be here. We're just removing an extra layer of complexity here. And I can just... Oh my god, what is this? Dot sat sets. Can I just like... It's not tracked sat set anymore, right? This is now tracked chord space. So tracked chord space or track is equal to... It no longer has... Like I removed this thing as a... I should be like that. Yeah, and I think that's it. Sat set, sat inst. Can I just like find and replace this? Replace all. And replace those. This can be removed as like remove that nesting. Sat set doesn't exist. Instead of sat set, it's now r sat inst. And any r sat set should be replaced with satellite instance. Sat sets. Is it inst or inst with an S? Yeah, okay. This doesn't have to be here anymore. Remove an entire indentation level. And what does this even do? Create draw entities. So this is supposed to loop through tracked chord spaces. Sat inst. Huh? I'm supposed to remove this actually. Yeah, remove a layer. Remove an indentation level. Tracked code space. Now move that there. And it doesn't need that anymore. Sat instances ID capacity. I don't know what this does. No, it just loops. Isn't this is just gonna loop through everything. It's gonna loop through all of the satellites in the universe. But I think I was gonna add like there should be like an optional thing somewhere here that I remember adding, but rtracked coordinate space dot sats ID, no error. Yeah. Tracked chord space, and that's now done. If this thing runs without segfaulting, that would be okay. At least it didn't build. Delete that. Another arrow up here. And now it's compiling. I don't have that funny linker that's like really fast. Not terrain. I want to see vehicle. No, universe. Give it a moment. The GPU, and it aborted. Crap. Oh yeah, well, there should be a useful error message here. Expected name, but we got data sources instead. Line 606. Okay. Line 606. Data sources. It's associated with that. This is associated with this argument. Why data sources? This should be sat instance. Should be associated with that. So I kind of lined these up. There's probably a better way to do this. I actually thought of a better way to do it, but not gonna implement it yet because this system kind of works. The pipeline framework and stuff like that here. Let's see now, universe. And there should just be rotating a little thing, and there we go. It completely removed satellite sets without breaking anything. Thing I'm thinking of adding next is intakes. Well, actually, this current implementation is still horribly incomplete because I don't actually know what to add. What thing that needs to be added next? This data accessor. I'm gonna need more circle path simulator. There has to be something to test the transfers. I'm thinking of adding this is incomplete kinematic sim. But I think I'll have to make constant rotation simulator. Just going to keep on just updating rotation and then expose rotation to something called it. Like I say, this is actually just plain C++ struct with data. And this set data thing is exposed to something called accessors. You can see where it's like you have position, stride, and a data type. There's a data type and what it is that is combined. And so it just shows giving a pointer to the address of X, Y, and Z, and just the stride between different, the distance in bytes between each, where the X's or the Y's or the Z's are located. And again, you got satellite ID as part of this thing here that's also exposed, so that whoever is reading this, which is the this is being read by the planet drawing system. So they're called features. So there's like a core universe feature. There's the test planet that adds the rotating thing. and soon like other stuff into the universe. And you see it depends on universe, depend on unicore, universe core. And then there's the when you open the window, you got test planets. That's test planet draw, the test planet renderer. Right, if I can, because the renderer is separate from everything else. So like if I open universe, oh my gosh, universe. When universe is opened, yeah, I can just close the window, right? And that actually destroys this feature. So everything here, all of this gets deleted. And when I reopen the window, typing Magnum, it recreates it and then reconnects it to the existing universe. So like this is just using the API that was created, was using the universe API by looking into the by reading the data accessors. Yeah, read the data accessors and then sees if it contains an X, Y, and Z. Has X, has Y, and has Z. Then do some stuff with some different ways of iteration and stuff. But yeah, what I want to do right now is make it so that the data actually like have multiple simulations writing into like the same satellite. And that means getting the rotation simulation, constant rotation sim working. So I'm just gonna copy paste this update function here. Constant rotation sim. Copy the function signature. Constant rotation simulation update and our simulation. So then we have data here. You just for loop through the data. You just straight up. This is simple for loop. Why is that sad? Just make that an R. Convention. And yeah, I don't know why you decided to use a I don't like the well, yeah, we're just saving indentation levels with this continue here. That's allowed to be null for some reason. Because this is designed to be kept very simple. It's not supposed to have like some kind of complicated way to deal with adding and removing instances. And actually, you can do the thing where if you want to delete, when you want to delete something, you just take the last, like, you have an array of stuff. If you want to delete something in the middle, instead of like shifting over everything, because to not leave an empty space, you can just take the element at the end and then move it into the thing that you want to delete, and just replace the thing you want to delete, and then shorten the size from the end of the array. The swap and pop is what it's called. And yeah, not gonna actually need those continues there if we're just gonna do that. Which means no empty spaces. This always has to be set to something. I don't even care about cycle time here. It's very similar. Yeah, you have all the same things here. And cycle time is just from 0 to 1, if I last checked here. It does a modulus on the period. Modulus on the period divided by the period. So there should be a value from 0 to 1 on where along, like, it's going to go up and it's going to go down. They're going down back to 0. It's going to go up, then back down to 0. This is like a sawtooth pattern if you keep reading this over time. Here it's using theta. It just multiplies that by 2 pi to have the rotation here. But here this is affecting like a quaternion rotation. So I can just say, you know, rsat dot rotation is equal to quaternion. Oh my god, okay, what is the documentation? How do I make an from Euler rotation? An angle. Is there like other, what are the functions here? Rotation. I have this rotation along the actually it's straight up the same theta. Theta and the axes. I think I can just do this. You know, like, okay, fine. Constant expression pi. There we go. I'm gonna use C underscore. No, I'm not gonna care about naming convention right now. I know I was caring about it earlier, but I'm too lazy. This is 0. No, let's rotate along the z, because I find it convenient to have z up in these cases. Because oh my god, quaternion d. No, just rad, and change that to an f. There's rad and rad d. Rad d is radian double. And I think that's that. For at least for that part. Now we actually have to make a rotation. A rotation simulator somewhere. And that's gonna be part of test planets. The test planet feature, which creates RSim. What is that RSim? It's confusing that there's gonna be oh god. Circle? Test sims. Circle. Circle simulator. Let's just like actually, what should I name this now that I'm changing this name? Circle? I should actually name it Circle Sim here. Circle Sim. Circle Sim ID. Reference to Circle Sim. Circle Sim. That just updates it. And instead of Circle Sim, we want what? Spin Sim. Kinematic simulator. Constant. Rotation Sim. There's circle, not a rotation. What if it's like spin? Spin. Is this a spin? Because spin is spin. There's a difference between spin and rotation. It also has a constant sim. If it's a spin, spin sounds like it's something you use in quantum mechanics, so it sounds cooler. Let's spin. You know, like just the spin of an electron. And okay. Constant spin simulator. We have to actually make one of these. And create chord space. Our circle sim is created up here. Oh. I have a feeling I should move this to somewhere else. And then it's like make circular path simulator for the satellite position. And set up data accessor to expose position and stuff. There we go. And let's still set up the accessor. And then down here we make that's the circular path simulator up here. So okay, we need constant spin simulator. To control the satellite rotation. There we go. Add one satellite. Make circles. So it's gonna be very similar to this. It's straight up is gonna be. I'm just gonna copy paste this. Problem with this is that it's gonna comment this out for now so that we can get errors. God damn it. Life hack. There we go. So these become error. I probably spent a lot more time just trying to comment out code than to actually write the thing. This is R. Now, what if this was in braces, in a scope? No, it's already in a scope. Circle path sim. Just see. Constant spin sim. Constant spin. Ah, my god, I don't even name it up here. Constant spin simulator. Spin sim. Rolls off the tongue very easily. Spin sim. I'm just gonna call it spin sim. Does it have an? It doesn't have an a simulation ID. I don't think this actually does anything right now. We don't actually need this here. I guess it's just here for organizational purposes. Radius. It doesn't have a radius because it's just a single thing rotating. And then set up data accessors to expose. Is there any? There's initial time. There's period. Axes. It doesn't have axes. Oh my. Okay. Why axes is right there? Why did I make it here? Actually, I didn't know there was axes. Oh, sat. Axes. Give this a default value just to be lazy, just to make sure it's just less likely that if it fails silent, so that it's more error prone. And error prone's funny, right? Period initial time. I'm just too lazy to set it down here. Spin sim. I just don't want to divide by 0. That's really it. Make it less likely to divide by 0. Albeit I kind of don't like default values because instead of things being set here, you know, you kind of scatter. This is fine. Okay, I'm already like criticizing myself here. So dot axes equals, you know, 0.0f, 0.0f, 1.0f. There we go. Done. Okay. I criticized myself too much. I try to justify my own BS. And we now need set up the data accessor. I feel like I should put this in a scope. Set up data accessor. Just making sure I copy the right things here. Remove the comment. For now, I'll think of a better one later on. Spin simulation. Wait a sec. In the default component, we have position x, y, z, watt x, watt y, watt z, watt w. That's a quaternion. So, I don't know if this is going to be pretty janky or not. If I say rotation dot data, Well, which one comes? How do I access the What are these quaternions for Magnum? Magnum quaternion. Underlying data type. And oh crap, modern C++. I can't read this. Oh, the member is gonna be below it. Vector and scalar. It's X, Y, Z, and W, right? I don't know. I don't know. I don't know. I don't know. If it's just dot scalar. Yeah, dot scalar. Dot. Wait, what is scalar? It's not a. That's gonna get you vector, and then X. Member references float is not. No, it's vector. I'm being silly. It's very dangerous that you getting. Oh my god. What is data? I think it's actually safer to use data in this case. Contrary to what document returns reference to a one-dimensional fixed size array of 4 elements. Vector first part, scalar after, so that's X, Y, Z, W. 0. Data 0. I was gonna get a pointer to that. Y, Z, and then W. And this is gonna be rot X, rot Y, rotation Z, and rotation W, and ID. This it's odd that some of these components are like refers to the satellite itself, and some of these are only for the accessor. It's fine though. It's fine. It's a tiny discrepancy. Wait. Rotation data 3. Instead of circle sim, it's spin sim. It doesn't have the accessor member. So copy paste. Huh? No, up here. There we go. Accessor. Copy that. Kinematic simulator. Paste. Oh, put this in a scope because we love indentation levels. Now I can uncomment this. Yeah, put those in there as well. And put that in there as well. Since this is a test, and also I'm not done the API and stuff yet, just repeat yourself already. Yeah, of course there's some repeating code here. I don't really care right now. It's not practical to address that. So we got spin sim. And see, they're both given the same satellite ID. So we have circle simulator, spin simulator, and both of them just have one satellite with the same ID. And that should be wait, what is this? Comps, data source, comps. What is, okay, wait, no. And then the data source actually points to two of these simulations. It only points to one of them right now. Instead of position. Pushback accessor ID comps. Circle comps. Now one of these is circle comps. I'm gonna need two versions of this because I can copy this 2 times. I'm gonna be lazy. I'm gonna put this up here. So that what is accessor ID? No, we're gonna have 2 copies of this. Change it back. Change it back. Well back. Accessor. There's one here, and was another one up here. Comps. So yeah, this has X, Y, Z. This can just be entirely automatic because I can just read whatever was here and just write it there, but you don't have to do that yet. What X, what Z, what Y, and what W, and that just happened to be in cursive. It kind of looks like it says not. Comps. Accessor ID. So now we have 2 data source. The data source has a list of a vector of entries that points to a data accessor and a list of components that's contained in the data accessor. Technically, this is redundant. If they can just read the accessor and just see what components it has, this typeset here is actually just like a bit vector. So this is straight up just like 2 64-bit integers. It doesn't have to be that big. Static ID set. Funny things there. It's 128 bits. And each of these in places, they're actually just flipping a bit. But it's disguised as an STD set. So like comps dot, it has begin, it has end and stuff like that. But on the inside, it's just bits. It's just a bit set. What we need to do now is add support. Actually, I want to run this and see if it crashes or aborts or anything like that. Because we've added support for rotating thing, but we've yet to add support for the on the drawing side. So the planet draw system doesn't know. It still works. It doesn't know that it doesn't know how to read that new value. At the same time, we also have to call update on it. Universe test planet draw. So they are the same thing here. We got circle sim dot data IDs, spin sim, and constant spin sim, spin sim. There we go. And let's just, this is not actually needed here. You see time is temporary, just static variable. I know it's stupid. It's stupid, but I'm gonna fix it later. Right, can I just use no, I can't do that. What do you call that thing again? ADL. I forgot what that stands for. Argument dependent lookup. I think that was originally the intention, but I just decided not to. No, sorry, just unnecessarily complicated random C++ stuff. So we got spin simulator here, read universe changes, and maybe a bit Cowo space. Is this even used anywhere? No, it's not. I'm gonna delete it. That thing's cringy. Create draw entities. Write draw transforms. If it has X, Y, and Z, then it adds it to the tracking thing. Why? So this is tracked tracking per coordinate space, seeing all the satellites in that coordinate space. It's taking access, or this has to be changed soon. This satellite ID is going to be global and stuff like that. Why is this like this? Why is it an unordered set? Accessors.inplace. So if it has relevant components that it cares about, has component X, has component Y, has component Z. I feel like this needs to be refactored. Even though I did refactor this thing twice already or something, it has... Instead of comp, what if these were all pos? Because we're all going to be... We don't want to write component 30,000 times. If it has an X, it has a Y, and has a Z, then it adds it to there. But why is it doing kind of doing the same thing down here? Of like, hey, if it has X, Y, Z, and then do this. Can this just be like if it has any significant component that we care about? And actually, you know, I'm gonna do the lazy thing. I'm just gonna put this to true. If true, yay. So this is always going to run. So you don't have to care about this part. Because we're probably gonna refactor that out, because I'm actually gonna probably like refactor out this bottom one down here. Because we got X, Y, Z iterating. Because if I understand correctly, this is actually going to be iterating the new data accessor that we added. There's going to be 2 elements in this RTRAC chord space accessors. If it's working properly, that is. Yeah, let's see. In the debugger, let's see if the text is a little small to see. RTRAC chord space accessor 2 items. Yeah, and that's exactly what I'm looking for. There's 2 items, 0 and 1. Which means that we'll iterate this twice. And now our instance here is going to be XYZW. Wait, are we missing a component? I'm seeing something. I'm seeing 4 in the element. That should be 5. Yeah, this is 0, 1, 2. This should be 3. And that should be 4. There we go. Okay. That should fix a bug before it ever causes any problems. You have stride X, Y, Z. This is gonna be gruesome. This is gonna be gruesome. Rot X, rot Y, rot Z, and rot W. It's gonna iterate. This is gonna iterate twice. For the first one, these are going to be set. For the second one, these are going to be set. Yes. Well, yeah. And then a gruesome amount of copy pasting. But surprisingly, this would actually be the fastest way to do something like this instead of do something more complicated. But stride what x, what y, what z, what w. If component type x, y, z, w. What y, what z, what w. You got satellite ID up there. Wait, why is that? This one's what x, what w, what z. Okay, got this right. Stride what x, stride what y. I'll clean up the repetition afterwards. Because, yeah, as the structure of the code reveals itself more, it has to be refactored. You can write it stupid initially, but then scrub it down. Wait, what x, y, z? What x, what y, what z, what w. And that should be it. Has what. Is equal to what x is not equal null pointer. P what x is null pointer, and what y is not null pointer, what z is not null pointer, and what w is not null pointer. And if it has what, you can actually support both. If we create a simulation, instead of two separate simulations, we can actually have one big simulation that does both constant spin and circle path, or whatever kinematic thing. And that's kind of like the intended beauty of this, is that you can structure universe stuff any way that we want. You can make it as optimized as possible, with very little restrictions, you know. R set to draw. Let's just copy paste this. Make it quaternion. Quaternion rotation, and you can just bitcast the space, and these are floats, right? Are they floats? Actually, I don't know if they're. What's the constructor for these, actually? Rotation, normalized from, normalized to, reflection, from matrix. Scalar, no init, identity. Oh, you need a vector and a scalar. Construct from a vector and a scalar. So just add another brace here. There you go. I don't know how to format that properly. What's this ASD thing? Satellite ID. And this is just gonna be sat ID. Ta-da. And draw entity dot rotation. No, I need to just, this one only sets the because a matrix consists of a translation part and then a rotation scale, pretty much. If I want to change just the translation, I think I can do this. Yeah, I know it looks a little bit weird for languages that don't have references, or that are. No, this is just straight up weird. The 3D translation part of the matrix, you can just set it like that. And then you can make a rotation matrix. And then replace only the 3x3 part of the matrix. Rotation, can I just what is it? Is this return rotation shear? That's a pointer, right? Now that creates a new matrix. I need something that's just a reference to the part. Can I get a reference to the 3x3 part? The thing is, how do I make, if I get the rotation, can I convert this to a matrix? To matrix. Yeah, there we go. But then how do I set the 3x3 part? Set the 3x3 part of the matrix. Draw transform dot. Can I put something in here? What if I do this? No, it doesn't. That doesn't work. Transform vector. What's com matrix data determinant. And I can just say I can get the rows and stuff like this. Equals that, right? Matrix 3. Foo is equal to this, and then I can just, I'm gonna do this a stupid way, aren't I? Up is equal to foo dot up. No. Foo dot. Can I index access this? Yeah, I can. But cast this to a vector 3. Which one is the up? Up is 1. Oh, we can just do dot xyz. Oh, so 0 dot xyz is equal to foo 0. And I can do this. 1, 1, 2, 2. Just repeat yourself already. And then 1. identify variable stat ID. Actually name the variables. Who names variables? Naming variables? Move this up here. Okay. Let's see now. Okay, okay. Universe. Oh, heap buffer overflow. No. Thanks, address sanitizer. It is supposed to be a 2. Alright, I don't have the breakpoint thing set yet. Oh, jeez. Where's that environment variable that I can set for, I'm a little too lazy to look it up. Universe 334. Components resizes to 5. Okay. Look at that. You fix one bug, you cause another bug. That's what C++ is like. And compiling. Did it run? Is it open? Here it is. Okay. Iteration method. Segmentation fault. Oh yeah. I'm using the wrong. Pivot X, pivot Y. I have a feeling static analysis is not gonna like this, like, pointer juggling parts. I'm not actually incrementing the stride and stuff like that because there's only one satellite. So I can just put like to do increment using strides. It's when and universe. Will it rotate? Okay, that part's running. Making sure that code path is running. And yeah, it's now rotating. It's rotating in one way. And okay, I'll change the periods. Slow down the orbit. But keep the constant spin. 10 times slower orbit. No wait, I changed that from 1,000 to 10,000. So yeah, 10,000. 10 times slower orbit. Universe. There we go. Yatta. We now have like it moving in a circle. Never move the floor. I can actually just remove that stuff actually if I go into scenarios. Magnum? It's just scenarios, so it's C++. Universe. The solar system scenario and the universe scenario. I can just remove the physics engine. Remove physics. No, I can keep the physics engine in there. I can just remove the floor setup function. It's funny, the entire physics engine can be changed out very easily. That was done before. Universe. There we go. A little easier to see. You still got the blocks falling, and you still got the balls. It's running in debug mode. It's not going to be that fast. But what I care about here is this little sphere. The little sphere rotating around. It's orbiting a point in a circular path. It's a circular path simulator. Puts it on a circular path. And a constant spin puts it into a constant spin. And I think that's all I'm going to be doing today. It's been a great one recording this. Yeah. Alright, you have a nice day.